All right, R7, radical expressions.
A B in personal finance.
I would drop personal finance.
I got an 90 on one quiz. I should have dropped that.
That's weird.
I also wonder sometimes how grades work.
All right, radical notation
I don't have simple math. Let me look at this.
for a to the 1 over n.
I think it's B.
Let a be a real number, n be a positive integer, and a to the 1 over n be a real number.
I'm so excited for my lunch history.
What the heck?
It was ruined.
Bro.
Then the nth root
So,
of a equals a to the 1 over n.
she makes no sense sometimes.
My lunch was used.
She graded our Pride and Prejudice paragraphs.
Okay. Yeah.
Yeah, but she just like takes off her weird stuff. Should have been easy on her.
Radical
Did you read the book?
notation.
Yeah. Alright,
I think you're going to be spending some time in the C category of your prayer tonight.
Alright, look, I didn't read the book, but I didn't, like, the parts that I didn't even need that. And, Taylor was my partner, we did Taylor. It was the one that we did the paragraphs with.
All right, radical notation for a to the m over n.
Who was your partner?
Chase.
It's, look, I'm not going to rewrite it. It's this stuff here, bring it down, plus the nth root of a be a real number.
I'm so excited for payroll. I'm really excited. For
Loved that.
But what's the arrow for?
Just this part that I underlined is also going to be down here. I just didn't feel like writing it a second time.
She's confusing.
It's a bad arrow. I'll fix it. And then where I had and a to the 1 over n be a real number, it just,
Plus.
the nth root of a now is how they wrote it, be a real number. Then a to the m over n equals the nth root of a raised to the m, which equals the nth root of a to the m.
Did we have parentheses?
I don't think so.
That's what I thought.
I didn't.
So glad. I'm like 95% sure that we didn't.
Probably not. All right, evaluating the nth root of a to the n. If n is an even positive integer, then the nth root of a to the n is equal to the absolute value of a. And if n is an odd positive integer, then the nth root of a to the n equals a.
I wish I didn't go out to lunch yesterday. Like today would have been a good day.
All right, next, rules for radicals. We're assuming A and B are real numbers, M and N are positive integers, blah, blah, blah. The product rule says that the nth root of A times the nth root of B equals the nth root of A times B. The quotient rule says that the nth root of A over B equals the nth root of A over the nth root of B. Bless you. Assuming B is not equal to 0. And then the power rule. The mth root of the nth root of A is equal to the mnth root of A.
That is a lot. This is a lot of review. 7 sections of review.
Well, one of them technically wasn't a review, but they believed it was.
Oh, the stats. The first section of review was not actually review.
All right, simplified radicals. An expression with radicals is simplified when all of the following conditions are satisfied. The radicand, which is what's inside, has no factor raised to a power greater than or equal to the index. Okay, the index is what's outside. So if you had something like the cube root of 81, okay, then we would need to take out 3 of the 3's, okay, but you take them out as 1 and be left with 3 cube root of 3. Okay, so this isn't reduced all the way, but this is reduced all the way. Two, the radicand has no fractions. Okay, which is going to tie into number 3. That no denominator contains a radical. So basically, those two things tied together, you need to rationalize the denominator. So if you had like the square root of 4 over the square root of 3, then we would multiply by the square root of 3 over the square root of 3 to get rid of it. Okay, and you'll see these as actual examples in a little bit, but those two things tie together. I don't know why they actually wrote them as 2 separate points, but whatever. Exponents in the radicand and the index of the radical have the greatest common factor, I'm just going to say GCF, of 1. Okay, so the same thing, like, again, 1 and 4 could kind of have been lumped together. If you have something that's got a big, like a power bigger than what your index is, you need to make sure you take it out, is basically all that's saying. And then this one is more of a if possible, but perform perform all indicated operations. So if inside you had like the square root of 5 plus 3 divided by 2 minus 7, something like that, make sure you've actually completed everything that's inside for it to officially be simplified all the way. I mentioned it briefly, but rationalizing a denominator essentially this is multiply it by 1. I should say by a form of 1. Okay, so going back to the example that I said a minute ago, if I had the square root of 4 over the square root of 3, well, the top in this case works out where the square root of 4 is 2, and I'm left with that over the square root of 3. But according to rule number 3, I can't have that. So I need to multiply this by a form of 1, which is going to be the square root of 3 over the square root of 3, which allows me to get rid of the radical on the bottom. So that's going to be 2 square root of 3 on top over 3. So it just allows the radical to go away.
Oh, I like this.
Remember, if you're adding and subtracting with radicals, you need to treat them as like a like term situation. You can't add the square root of 2 plus the square root of 5. Okay, well, you can add them, but that doesn't become the square root of 7. Okay, that's the square root of 2 plus the square root of 5 is just how you would leave it.